Good afternoon.
Good afternoon.
All right, so let's see. Hannah, could you move your camera down? All right, Skylar, are you feeling lonely today?
Oh, yeah.
A little bit. Well, I appreciate you coming even on your own. So good job. Uh, let's see. Do we have? Looks like everybody's there at St. John's. Yes. Okay. So we're just missing Chloe today. All right, so let me tell you about, so the schedule this week is that we're going to try to finish up chapter 8 this week, and then I'm thinking that maybe next Monday, and I'll let you know for sure on Thursday, but I'm thinking Monday we're going to have a Moodle day, and the reason why is because I want to squeeze in the test, the chapter test, chapter 8, and then next week on Wednesday and Thursday, I want to have the midterm. Okay, so the midterm will be next Wednesday and Thursday. There's 2 parts to it. You only get 1 attempt for each part. And then your overall grade on the midterm is the average of the 2. Okay? So they're 2 separate parts, not the same questions or anything. Okay? So that will be Wednesday and Thursday for sure. The Moodle day, I haven't figured out if it's going to be Monday or Tuesday of next week. So right now, I'm kind of hoping that we can have the Moodle day on Monday. Okay? Now, also, what that means is that, like, so we'll take some quizzes on Wednesday and whatever, but it also means that if you owe me anything from chapter 7 or 8, it has to be caught. You have to be caught up by next week. So when we take the midterm, chapter 7 and 8 are going to be locked. Okay. So, questions about that?
So, Professor Strong, I emailed you last week about the first attempt on one of the quizzes. I think it was 8.1.
Right.
And so I don't know when. Well,
so you tell that you were kind of asking me if you could make it up, and I would say yes. So you just let me know when you can, and then I'll open it then.
Okay.
So if you just talk with Crystal and just let me know, okay?
Okay. And do you want me to email it to you or just?
Yeah. Well, you can tell me right now if you know.
Okay. Yeah. Could I do it tomorrow from 1:50 to 2:50?
Sure. And then what was it?
I think 8.1, and then the second attempt on this chapter 7 test.
Perfect. Okay. No worries. All right. Anything
Mr.
else?
Strong?
Yes.
So tomorrow at 10 o'clock, can I have the chapter 7 test reopened so I can finish that and submit it, and then the 8.2?
Yeah, I think I already did those for you.
Okay, thank you.
Unless these aren't different ones than were in your email, right?
No.
Okay, so I think I did that for you already. Okay. But if something happens and it doesn't open, shoot me an email or something, okay? Text me, okay? I think I missed your one this morning by like 1 minute, by the way. Because I checked it sometime between 9 and 9:15, and that's about when your email came in. So if I would have, anyway, I could have got it this morning if we hadn't, anyway, bad timing. All right, anything else? Oh, Hannah, when did you need that letter?
By March 9th.
Oh, we got loads of time. Okay.
Yeah, you got plenty of time.
No worries. I just wanted to know if I needed to put it to the top of the pile this week. So,
Oh yeah, we can stay on the
Okay.
bottom. That's fine.
all right, we'll take care of it. All right. Well, so we were in the practice 7 on 8.5. So if you get that out, and I had wanted you to finish that, and we'll go over it right now. Okay. So we were doing the Heaviside method to find A and B. All right, well, so let's see. Did anybody go through and finish the whole thing? Of the final answer?
I think I have it.
Okay, all right. Tell me what you've got and let's check.
I have negative 0.375 ln, the natural log of the absolute value of x plus 0.0625, the natural log of the absolute value of x plus 2, plus 0.625. Yeah, I can't read my handwriting there, but something. Yeah,
A natural log of x minus 2
yeah, that.
plus c. So I think you just misspoke on the first coefficient because that's negative 0.375 and you said 3.75.
Yeah, that's what I meant.
Yeah, okay, because otherwise you had that right. Okay, so now, you can do them as decimals, like Aiden did, or I just left them as fractions. Whatever works for you. Would anyone like me to, if you didn't work it through, write down the answer, but is there anyone that would like me to actually work it through? Remind you kind of how we're doing it. All right, so Joran, did you get the A, B, and C?
I was gone Thursday,
Oh,
so
okay. I did post the video on Friday.
Thank
So,
you.
well,
I
it's not
just
going to
want-
really.
I just
Is
want
that-
the problem so I can go and look at it and know what
Okay.
I'm doing.
Okay, all right. So I'll just kind of go through it, and if you don't understand it, then after you watch the video, if you still have questions. So the first thing we do is you factor the denominator. So you have 2x times x plus 2, x minus 2. And then you're going to have a over the first factor, 2x, b over the second factor, x plus 2, c of the third factor, x minus 2. So then to find a, b, and c, the shortcut method that we learned, this only works with linear factors, is what's called the Heaviside method. And basically what you do is you cover up the first factor, 2x, and then plug in what would the 0 for that. So you plug in 0 everywhere else for x, and then that gives you what a is. So if you plug in 0 for x, you get 3 over 2 times negative 2, or negative 3/4. So a is negative 3/4. Then you cover up the second factor, and then you plug in negative 2, the 0 for that. So negative 2 plus 3 is 1. Negative 4 times negative 4 is 16. So b is 1/16. Okay, and then C, you cover up the third factor and plug in positive 2. So that would be 5 over 4 times 4, so 5/16. So C is 5/16. Okay? Then you put in A, B, and C for each one. So negative 3/4 times the integral of dx over 2x plus 1/16 times the integral of dx over x plus 2 plus 5/16 times dx over the integral of dx over x minus 2. So all these end up being natural logs. The only thing here is on this one, you need a 2 up top. So you have to multiply by 1/2. So that's why this becomes negative 3/8 natural log of the absolute value of 2x plus 1/16 natural log of the absolute value of x plus 2 plus 5/16 natural log absolute value of x minus 2 plus c.
Thank you.
You're welcome. Okay, so now part 8 and 9 on this, I looked through and I couldn't find one problem where it helped to know these. As I think the Heaviside method is the best way to find A, B, and C if they're linear. And so I'm going to just skip parts 8 and 9 and say we're done with 8.5. All right, any other questions on that? Okay. All right, so let's go to 8.6. Now, 8.6, I really like this section for a couple of reasons. Number one, after that algebra intensive 8.5, this is like a breath of fresh air. And then number two is 8.6 is kind of like how they do complicated integrals in real life. If you're an engineer, you're not going to spend, even if you're trying to do an integral that you can't put in the calculator, so like an indefinite integral, usually you don't spend like a couple of hours doing integrals. That there's two ways that you do it if you're an engineer. Number one is you do it with integral tables, and number two, you might use a computer algebra system. Okay, so I'm going to introduce each of those to you. Okay. All right, so a brief table of integrals is provided at the back of the book after the index. Okay, so hopefully you've got a book with you or a book that you can share or something. If there's one on the bookshelf, grab it because we're going to need it for a little while. Okay, so what I want you to do is find in the back of your book the brief table of integrals. So after the index, just flip through and it's before the answers, I think. Let's see, is it? No. So there's the answers to the odd problems, the index. Okay, then the brief table of integrals. So it's T1 through T4, 5. Okay, so there's 5 pages. So if you're an engineer, you actually might have volumes. You know, just like lawyers have law books with all these cases, I've actually seen engineers have volumes and volumes of integrals. All right. And so that seems a little crazy. But you don't actually see that as much because a lot of that is digitized. And so you can search it much easier than having it in big volumes. But I am going to teach you how to search through this brief table of integrals. Okay. So, all right. So let's say we wanted to find this, the integral of x, 3x minus 4 squared, okay? So here's the deal, is the first set of integrals are the basic forms. The first 20 are like ones that we've done in Calc 1 and Calc 2 to this point. All right, but that's not one that we would have memorized. All right, so then the next set, forms involving ax plus b. All right, so that's kind of where this is going to be. So the ax plus b, you have a coefficient of x, and then the b could be positive or negative. Okay, so what we want to look for is a formula that has an x in front, and then ax minus b to some power. All right, so you look through those. Do you see that anywhere? That pattern.
Yeah, number 22. Yep.
22? Is that what you're going to say? Okay, so 22. Now, so when I'm doing these problems, I actually like to write down, okay, the formula that I'm actually going to use. So this is number 22, all right, and this is the formula from the book, all right. Now, then I also like to write down what I'm plugging in, all right. So the A is the number in front of the x. The coefficient of x is 3. So I'm going to plug in 3 for A. The constant is B. So here, if you have a negative with it, we're going to plug in -4 for B. And then the n is the exponent. And so that's 2. All right? So what I'd like you to do then is to finish off this practice problem, plug in 3 for A, -4 for B, 2 for n, and then try to simplify that. Okay? So you're just plugging into the formula. You don't have to make any decisions at all. All right? So just kind of compare your answer to that. That's what you get when you plug in and then simplify. Okay? Any questions on that? Anyone have any difficulty at all in any part of it? All right? Okay, constants in the formulas. The integration formulas are stated in terms of constants, A, B, and C. Those are usually your coefficients. And then M and N are usually reserved for your exponents. All right, so let's see if you can look for practice 2. And I'm only going to give you about 30 seconds and then see if you can find. All I want you to do is just find the formula. Don't start plugging in yet. You want to make sure you have the right formula. All right, has anybody found the formula yet? Okay, well, look up here. Let me show you why this one's hard to find. It's because of the way that it's written. See, when you have, most of the formulas are written in exponential form. And so if you rewrote it like this, now you're more likely to find the right formula. So sometimes you have to rewrite it so that you can see it. All right. So now look. So if you find it, just call it out.
Is it the same one we used last time?
It's the same one, 22. And my point is that even though we just had used that formula, because the problem looked different, you somehow don't think it's going to use the same formula. So, but it does. Okay, so this time your A is, so it's the same formula. Your A is 1, B is -2, and N is a fraction. So sometimes your coefficients, your variables, your exponents, they can all be fractions or decimals. Okay, so go ahead and plug that in and see what you get. All right. So let's. So on this one, when you plug in, you need to do a little bit of algebra here because we don't ever want a complex fraction. So dividing by 3/2, dividing by 1/2, you need to multiply by the reciprocal. Okay, so to make sure you take care of that. All right, otherwise it's fairly straightforward. Okay, any questions on that one? Okay. All right, using multiple formulas. Sometimes necessary to evaluate more complicated integrals. So what that means is that sometimes you'll do one formula for like the first part, and then you have to do another formula for the second part. So you might have to use more than one formula depending on how complicated the integral is. All right, so let's try that one. Practice 3. All right, so Joran, what formula did you use first?
Number 28.
Number 28. Oh, I used 30. Okay, so let's look at 28 and compare it to 30.
28 is the same except for an x squared. It's an x.
See, yeah. So because you have an x squared, you can't use 28. So now if it has like x to the n where you can use it, see 30 you're divided by x squared. So that's why you want to use that one. And so here I'm going to use plug in A for 4 and B for 1. Or 1 for B. So here's the thing. So you plug in, all right, first part, no problem. But the second part is another integral. So go ahead and plug in, simplify. But when you get to this part right here, you're going to need another formula. So that's what I'm talking about. Sometimes you have to use more than one. So, Joran, what one would I use for this one?
Number 29.
Number 29, let's see. There we go. Now, 29 has two versions of it. There's 29A and B. So what's the difference?
One has an ax plus b, the other one has an ax minus b.
Yes. So a lot of times it doesn't matter, because if your B is negative, you don't plug it in. This one, it does matter if the B is positive or negative. So since the B is positive, you'll use 29A on this one. Now, when you write your final answer on this one, don't forget to include this first part from the first formula, okay? The most common mistake on this is actually just doing the 29A and then forgetting that you had that first fraction from the beginning, okay? All right, any questions on that? So like here, the square root of 1, we can clearly simplify to 1, but the square root of 4x plus 1, that doesn't break down, and you can't cancel it because it's not a factor, it's a sum. So that's all we can do there. Okay, is this feeling easy or hard to you?
Pretty easy.
Pretty easy. Any questions? It does actually make me a little nervous when there's no questions, because then I don't know if it's like so easy or if it's It's so hard. Okay. Well, okay, so the next type are what are called reduction formulas. Okay? So reduction formulas can sometimes shorten the time required for repeated uses of integration by parts. You might even remember when we did the integration by parts page and we got to a reduction formulas, and I just decided I was going to skip that. And so I skipped part of that integration by parts because to do that during doing integration by parts, it's where you have to do integration by parts maybe 4 or 5 times, and it's not like the tabular integration where it's just quick. Those just take forever. And so knowing that I was going to come back to that in just a few sections, anyway, so today's the day where I show you how to do it the easy way. So not doing integration by parts 5 times. Instead, we're going to use a reduction formula. Okay? Now, let me just kind of show you in general why it's called a reduction formula. You don't need to write any of this down here. Let's see if I can. Okay. So the idea is that let's say you have a function to a high power, so to the 5th power or whatever. So then you can use equation 93. What it does is it breaks this exponent down by 2. Some of them reduce the exponent down by 1, some of them by 2. So you have this part in the middle, and then you apply this to the same number, 93, and you break it down. And so then you end up with, well, then finally the integral of tangent, that's number 89, is the natural log of the absolute value of cosine x. So you'll do 93 to break down the exponent from 5 to 3. Keep this part in front, and then you'll use 93 again, and then you'll break this down, and then you use 89 to get the last little bit. So now if you go back to the table again, to the table of values, see the trig forms start at number 63 all the way to 102. And then the inverse trig forms. And then, so for your practice 4, you're going to use one of the next section, exponential and logarithmic forms. Okay? And so which one would you use for practice 4? The natural log cubed. Which formula would you use for that?
$117.
Okay, so 117. The thing there is that it does have an x in it, and so what you think of is you let the exponent on the x be 0. Okay, because there's no restriction on that doesn't say you can't do that. So use number 117, but let n be 0, so that'll take care of your x to the n. X to the 0 will be 1. So you don't have to worry about that. And then it'll break it down to 1 by 1 each time. So you're going to have to use it a couple of times. Okay, so now here's the thing, is that when you are doing these, a lot of times you'll find better formulas, better tables in different books as you get more experience. So there's actually 3 reduction formulas that are on page 478 in your book that are actually easier to use than number 117. And so that's why, why there's tables and tables and tables of books, is that they're always like something a little bit better. So this one right here that I have written down is actually from that page. And if this were my book, I would go ahead and write that down as like 117A or something like that. I would write it in on that page. I don't know if your school cares if you write it in or not, but it's an easier formula to use, because if you don't have the a to the x or the a to the x to the n, it makes it a little easier to plug in. Okay. So I kind of hate that they don't put those in from the beginning, but anyway. So when you apply this rule or 117 and simplify it, you end up with x ln of x to the third minus 3 times ln of x squared. But then you use the reduction formula again, and it's going to be x ln of x to the third minus 3 x ln of x squared minus 2 ln of x dx. And then number 116 does have the integral of natural log, which is x ln of x minus x. And then you put the plus c at the end. All right, anyone have any trouble with that one? Plugging into that 117 formula, or anyone having trouble, anything you want me to explain? I know in my morning class, they were a little concerned about where the 6 came from. And it's because this coefficient, the 3, applies to this whole thing. And so when I simplify ln of x squared, the 3 is in front of the whole thing. And so when you distribute, it distributes, the negative 3 distributes with the negative 2. All right. Any questions? So I mentioned that's one of the ways that, if you're trying to do a report for your boss and engineering firm, and you have to figure out a stress test on a bridge or some object or whatever it is you're working in, you're going to have to do something. And so, anyway, so that's one way that you would do it, is you would use these formulas, the tables. Okay. Now, the other way that we do calculus in real life is to actually use what's called a CAS, or computer algebra system. Okay, so if you're an engineer, you're going to get a calculator or use computer software that won't just do calculus for like definite integrals like the TI-84 does, but it'll do calculus for everything that has a CAS. Okay, so back in the 70s, there was a Canadian company called Maple, the maple leaf on the Canadian flag, okay? And that was really the first engineering software. And then Mathematica came out, and it's was quite an improvement. It does a lot of 3D graphing and so on. And now it's actually kind of housed by Wolfram Alpha is a company. And you can actually buy a copy of Mathematica on your own, okay? But unfortunately, it costs hundreds of dollars. I actually observed a teacher that just taught calculus only using Mathematica. And the thing that was amazing about his students is that they could model real world problems that had, all the numbers weren't integers. They were decimals. They were ugly integrals to do, but they could do them on the calculator. The problem is, the reason why I decided I wasn't going to teach that way is because the students had no idea of how, like the derivative of the sine or the integral of x squared, or they didn't know, even the most basic calculus. So, because they relied so heavily on it. But I do want to show you really quick this website, Wolfram Alpha. And it actually applies computers to a variety of subjects. So like if you're taking engineering or physics class or chemistry or whatever, I would highly recommend that you play around with this, and you'd be amazed at some of the stuff. Household math, entertainment, personal finance, just about anything. Okay, so I'm going to go to calculus. All right, see, it will actually compute an indefinite integral. So it's not like we have to have limits of integration anymore. So integrate x squared sine cubed x. Okay, or I could type in a different version of that. And so it just basically cranks it out. The answer shows you some different plots of the integral on different scales, whatever. Okay? There's a lot of things. Now, to get the step-by-step solutions that you would need, though, you have to buy the software or get a subscription, and different plans cost different amounts. Usually when you're a student, you can get the software for like $150, whereas if you're a professional, it might cost you $500 or something like that. But this website is free. You can do a lot with it. And as a matter of fact, most of your homework you could check on this Wolfram Alpha site. Check your answers. But I don't want you to use it for quizzes, tests, any assessments, midterm, final. That will be cheating. Okay? So don't do it. All right, but I'm just trying to show you what's out there. Okay, now let's see. If we have a definite integral, let's do this. So integrate sine x, and we have limits of integration. So it'll not only give you the answer, but it'll show you the area under the curve. And then you can kind of see different things. Again, the step-by-step solution, if we click on that, then it'll say, some of them for the demo, they'll give you the steps, but then to show all steps, you have to get the pro version, okay? But I did have a Calc 2 student that took me for Calc 3. Anyway, he got the student version for his smartphone, and he told me it didn't cost all that much. And I think he bought like a year subscription or something like that. He used to use it all the time when he was ever stuck with a homework problem, and he really did it the perfect way. I think it helped him understand what was going on, especially in Calc 3. There were times where if we couldn't see what was going on, he'd graph it in 3D and show it on the phone. It was amazing, okay? So there's a lot of power to this, all right? Now, on your sheet, I mentioned, one other thing. There's also a TI-89 by HP, or an HP calculator that actually will have a computer algebraic system. Where, it'll do things like factor, do polynomial division. Everything that we do in algebra, it does. But those are not allowed on, like, SATs or taking the AP exams or anything like that. Okay. But as an engineer, you probably would get something like that. So on page 482, and I've got this listed on the sheet, okay? I'm actually offering a little bit of extra credit. If you want to go around and play around with the Mathematica and work those problems, it says read the examples, work the problems, but I want you to print out the work, and then you're going to have to like scan it and email it to me or take a picture of it or whatever. And if you email it to me before the midterm, then I'll give you 5 quiz points, extra credit. So if you have a couple of 4s and a 3 or a 2 or whatever, those little quiz points can help bring those scores up. Okay? So if you want to do it, it's not going to be, you're not going to be tested on anything on Mathematica or anything. Okay? It's just kind of want you to see what's out there. All right. Any questions before we drop off here in a minute? All right. Well, thanks, you guys. Tomorrow we'll start in on 8-7. Okay. Have a great afternoon.